Section 1.7, Transformations in the Coordinate Plane. By the end of this lesson, you should be able to write mapping statements from pre-image to image for a transformation using arrow notation. You should be able to identify reflections, rotations, and translations, and you should be able to find the image points for a translation given the rule in the coordinate plane. So a transformation is a change in the position, size, or shape of a figure. The original figure is called the pre-image. The resulting figure is called the image. So the pre-image is what we start with, and the image is the end. A transformation maps the pre-image to the image. Arrow notation is used to describe the transformation, and primes are used to label the image. So in this first image, this start here, we have triangle ABC. And then this arrow says that we did something to it, that we transformed it into triangle A prime, B prime, C prime. So these primes, these little slashies next to all the letters, just means that B went to B prime, A went to A prime, and C went to C prime. It's like the new version of those letters. So these are the transformations that we're going to talk about in this section: a reflection, a rotation, and a translation. A reflection is a flip across some line called the line of reflection. Each point in its image are the same distance from the line of reflection. So if this is my line of reflection, if I were to measure this distance right here, it would be exactly the same as this distance here. And the same thing with point B. From the line of reflection to point B is exactly the same as B to B prime. And obviously the same thing with A. A reflection is kind of like a mirror image. It flips it over something. It could be a vertical line like this, or it could be a horizontal line. So remember those hearts that you used to cut out back in the day? You take a piece of paper and just cut like this, and when you opened it up, you got a heart. That is a reflection. A rotation is very similar, except you have some point P that you're turning something around. So this right here, we turned it this way. We started with F and went to F prime. We started with E and went to E prime. Each point in its image are the same distance from point P. So we have this G right here in our original mapped to G prime here, and those are exactly the same distance. You could do the same thing with D and D prime, exactly the same distance. With all of them, it works. Like turning a doorknob, it's the same thing, you just moved it around, or tightening a screw, same thing, you just switch the orientation of it. And then the last one is a translation. This is where you just slide something across the paper or across the desk. All the points move the same distance in the same direction. So if we were to measure from J to J prime, it would be exactly the same distance from M to M prime. Exactly the same distance from K to K prime and from L to L prime. All of those distances would be equal, and they're all in the same direction. So example 1, identify the transformation, then use arrow notation to describe it. So if we look at this first one with these triangles, the blue is our pre-image. That's what we're starting with. So we started with triangle A, B, C. And we want to see what happened. So when I'm looking at this, A just moved down a little bit, C moved over and down, and B moved over. So if I want to identify what this is, I know it's not a slide. This picture didn't all move down in the same direction. So we can cross off a translation being a possibility. There's not a line that it looks like it flipped over. So our only guess is that it has to be a rotation, that C went to C prime, that B went to B prime, and A went to A prime. So this is a rotation. And triangle ABC got rotated to triangle A prime, B prime, C prime. The arrow notation is just telling you that something happened, that it got transformed. So if we look at this next one over here, remember the blue ones are what we start with. That's our pre-image. And then we end up with the red ones with all the primes. Now, this could be one of two things. Well, it could be rotation also. Now, it kind of looks like this just got slid down, like D moved down, G moved down, E moved down. So we could think it's a translation, but look at your letters. If D just moved down, it would most likely be right here, and it's not. It's over here. So if we want D to come further than G, our only option is that it's a reflection. And it's a reflection over this line right here. It's like we folded this in half and all of these points mapped up to their counterparts. So for this one, we say that D, E, F, G transform to D prime, E prime, F prime, G prime. Simple as that. So a figure has vertices at A, B, and C. After a transformation, the image of the figure has vertices at A prime, B prime, and C prime. Draw the pre-image and the image, and then identify the transformation. So let's make our pre-image red. A is at 1, negative 1. B is at 2, 3. And C is at 4, negative 2. Now it doesn't really matter what this shape looks like. In this case it's a triangle. And now we have to map the image, all of our primes here. So A prime is now at negative 1, negative 1. B prime is at negative 2, up 3. And then C prime is at negative 4, negative 2. So hopefully your brain's already thinking about what happened here. Since the A's are really close to each other, the B's further apart and the C's further apart, that means that it can't be a slide. That also means chances are it's not a rotation. So the only one we have left is a reflection. And we can see it got reflected over the y-axis. Each one of these points are exactly the same distance away from the y-axis there. Last part. To find the coordinates for an image of a figure in a translation, add A to the x-coordinates of the pre-image and add B to the y-coordinates of the pre-image. Translations can also be described by a rule such as our xy, so these are the first set of coordinates, get translated, remember that's what the arrow means, to whatever your x was plus a random letter, plus whatever your y was plus another random letter. And if you have a shape, any shape you want, and you add the same thing to your x's and y's, it will translate the image to make the same thing somewhere else on the graph. So that's what we're going to do with this next one. Find the coordinates for the image of ABC after this translation. So what we're going to do is to every x value add 2, and to every y value add 1. So we're going to move everything over 2 spaces and down 1 space. So if a point was up here, point whatever, we're going to move it over 2 on the x-axis, down 1 on the y-axis. So let's come up with the coordinates for all of these points first. Point B is at negative 3, 4. Point C is at negative 1, 1. And finally, point A is at negative 4, 2. So now to all of our x's here, I want to add 2. I want to move it over 2. So if I add 2 to each one of these, I'm going to end up with negative 1 here, 1 there, and negative 2 here. And then to each one of the y's, I want to subtract 1. So 4 minus 1 will give me 3. 1 minus 1 will give me 0. And 2 minus 1 will give me 1. So these points right here are B prime, C prime, and A prime. So the first one, -1, 3, right here, is B prime. 1, 0, here's C prime. And then A prime is -2, 1. If you look, we made exactly the same shape. We just moved every point over 2, down 1, over 2, down 1, over 2, down 1 for every single point. So, you should be able to write mapping statements from pre-image to image using the arrow notation. You should be able to identify reflections, rotations, and translations, and be able to find the image points for a translation if I give you a rule. That was the thing we just did. Hope you have a good night.